lights.
I mean the group one. I can't understand. Last question. Huh? I understand there's a map and all in the last. I understand that. And just like go together.
Good morning.
Good morning.
Good morning.
How's everybody doing today?
Tired.
Yeah, I feel that. So, sorry for my tardiness. I've got my class before this is like all the friggin' way in the friggin' hospital. It's quite the commute, especially when you've got students like hanging on, asking you questions, and like never walking fast enough, you know? God, friggin' undergraduates. Anyway, test dates have been posted. Check the Avenue announcement feed. If there are any conflicts with any of the dates which have been posted, please inform me. Basically, I asked the bookings to give me slots in the evenings so that nobody would have any conflicts with any classes. And then they give me slots at like 4:30 in the afternoon. And I'm like, but that's during regular class time. And it's like, they also double booked me for midterm number 2 and the midterm for another class that I'm teaching. So somehow I'm mysteriously supposed to clone myself, learn how to clone myself by the time we hit mid-semester, which, don't get me wrong, that would be useful. But, you know, even if I cloned myself, I would have like 2 of me making half the money that I'm making, which is probably not enough. So I'd have to go send my clone to find more profitable work anyway. Anyway, so, functions then. We've been sort of chewing our way through this material on the construction of expressions, roughly coincident with the assignment 1 material. We're going to talk now about functions, which are, you know, things you'll have to know in order to do anything in this course. We're going then to talk about tuples. We're going to very gently and easily drop you right into the middle of linear data structures, they being very useful. You'll appreciate that, I hope. And then we're going to talk about strings at some length. Strings are another extremely useful and basic thing that you need to know about. So, let's get on with it. So, a function. Functions have a particular meaning in computer science. As you might expect, many other things have had particular meanings in computer science, including variables. In general, functions are meant to mimic the behavior of mathematical functions as called, as used in regular mathematics. However, in computing, you sort of have this ability to define your own functions. Functions used to be called subroutines. Basically, you take a series of instructions, you package those up in such a manner that they can be reused often and with stable input-output characteristics. So if you have some kind of sub-part of your algorithm, it is often useful to package that up as a function, right? The rules concerning good function creation are, roughly speaking, the good rules of software development as we've seen them so far. You want an emphasis on modularity, right? You want every function to perform one task, perform that task well, using a strictly specified series of inputs and outputs, right? That way, you can take all of your functions and put them together like Lego. So, good. This is the syntax for functions, in Python at least. In Python, all functions are declared with the def, or define keyword. You then select the name of the function. The name of the function is an identifier, similar to the identifiers used to name variables and other things. You then have a comma-separated, parenthesis delimited list of inputs. In contrast to other programming languages you may have used, Python does not require the use of data types to type arguments. Just like everything else in Python, it'll just assume what you meant, or try to at least. Honestly, it's pretty good most of the time. Colon. Next line gets tabbed. Everything at one level of tabbing is inside this function. Right? The next function should be one level of tab removed. Right? The body of the function is composed of all of the statements, all of the if statements, loops, assignment statements, function calls, etc., which we have been studying so far. And finally, in order to give output back to the thing that has called the function, it is necessary to use a return statement. The value that you are returning is the output of the function. So, let's disabuse you guys of some common misunderstandings. Too many times in my day have I seen students assume that all input goes into programs through the terminal, and all output comes out of programs through the terminal as well. Printing the results of a function does not count as outputting it to the function. It counts as outputting it to standard output. It's not the return value, right? When we ask you to write a function in an assignment, and all we do in assignments is ask you to write functions, when we say the function should output X, we mean the function will return X. Anybody who just dumps it into standard output is not doing their job correctly. And this also applies to gathering inputs using the input function. The input function is used to gather user prompts, user information from a command line interface. When a function has inputs, when it says in your question, this function has x, which is an integer, and y, which is a Boolean, and these are the inputs to the function, it means they appear in this list of inputs. I am not asking you to write a command prompt to gather them from the user. Make sense? Basically, anything that any function that you write that uses that style of input and output will be marked wrong. So don't use it. Okay? This is not to say that there aren't valid programs that prompt the user for input. That's obviously the case. But in this case, we want you to write a function, which is a component of a program, not a whole program. In theory, if you were to put together a program to use the function, even, you could easily write a wrapper that asks the user for the input to the function, throws it into the function, and then outputs the results of that function using printf. That's how I do it all the time when I'm showing you examples, right? You'll notice that I rarely, if ever, will put an input function inside of a call to input inside of the function itself. Have I made myself sufficiently clear? Okay, good. So, here's an example of a function. We have defined Pythagoras. Z is equal to x squared plus y squared. Return z to the power of 0.5. So this is our long familiar function, equation, whatever, for calculating the length of the hypotenuse of a right-angled triangle. Any questions? How many people have started assignment 1? Good. That wasn't due last Sunday, was it?
No.
Okay.
Maybe this Sunday.
Okay. So, here's another question. A is 4, B is 5. What's 3 times A plus B? Let's see, shall we? Oh, come on, don't yawn loudly in my class, jeez. We get an error. Int object is not callable. So the syntax for calling functions is to have the function name immediately followed by an open brace, and then however many arguments you're giving it, and then a close brace. In algebra, this is shorthand for multiplication, but it is not shorthand for multiplication in computing code. If you use the number 3 like this, it assumes that you meant to call 3 as a function. Of course, 3 is an integer and not a function. So, to call an integer as if it were a function will give you an error saying that it is not callable. Make sense? Incidentally, if you want to run a function that does not require any inputs at all, the parentheses are still required. You open and close the parentheses. If you leave out the parentheses entirely, what you are left with is actually a reference to the function, which may be useful later on when we talk about functions. Did you have a question?
Yeah, can you have like 3 as the name of the function? You have a number as the
Let's see. Def3. Nope. Identifiers can't start with numbers. So there you go. Good, that's an interesting question. Any questions about that? Good. So let's talk about tuples. How many people have used arrays before? Good. I think I could probably skip through this stuff faster than I am. So, in contrast to the types of data structures that you will have probably, okay, how many people have never used an array or a list or a tuple or anything of that sort? Okay, all right, sorry. You guys should be vocal as well, because like I sometimes get the impression that everybody in the room can program, because like, you know, a large number of people in the room can program. So I need to keep in mind that you guys are in the class. So please be vocal with your questions. Anyway, so we've talked about variables, right? You sometimes get into a situation where you want several variables to hold several different related values, right? If you're in a situation where you catch yourself saying like var1, var2, var3, var4, var5, var6, etc., and do a long line of them, you are in a situation where you could benefit from a data structure. So data structures allow you to collect up a large number of variables, give them one common name, and access the individual elements within them, within this structure, using what's called a numerical index. So basically, this is the first element, that's the second element, that's the third element, but the way that you access them is by calling for 0, 1, and 2 for reasons that can't be properly explained until you know how to program C. So the objects that you collect up into a tuple may be of many different and disparate types in comparison to many other languages that you may have used, such as Java. I believe Java arrays are monotyped. Anybody Anybody confirm that?
Yeah,
What?
it's more.
Yeah, there we go. So, so Python doesn't have an array data type specifically, right? It's got tuples, lists, strings, sets, and dictionaries. Most of the time, people use lists for everything. Pretty much all of these data structures allow multiple different data types to coexist inside of the same data type, or inside the same data structure. Things like arrays in Java or C require all of the elements inside the data structure to be of the same type. This is not the case in Python. In Python, we may have an integer, a floating point number, a string, a boolean. We can even have other tuples inside these tuples, etc., etc. We can put any number of items we want into a tuple. They stay in order. That's only interesting or important in contrast to sets, which do not have ordering, officially anyway. We can assign a tuple to a variable. So the thing that makes tuples different from lists or arrays is that tuples are immutable. Once a tuple has been created, you cannot modify it except through destroying it and recreating it. All right? So, for example, now do you guys know why everybody tends to use lists? If we have a tuple, right? There we go. T at 0 is 1, T at 1 is 2, T at 1 equals 5 is an error. Tuple error, tuple object does not support item assignment. Those of you who are more used to programming may say to yourselves, my goodness, that seems like an oversight to not have assignment, an operation you can perform over your data structure. I can't imagine why it would be the case that you would need to do that. We'll get into it when we talk about data structures. For now, it's simply, for now, all we need to know is this basic set of operations over tuples. Some of these guys, one of these operations creates a new tuple from two older tuples, rather than modifying tuples in place. Make sense? So, I already demonstrated, but item retrieval or indexing is performed using square braces. If you are not, if you're not yet hip to all of the different types of braces that will be expected of you, every type of brace that you see that is different is important. It's important that it's different. If you use round braces where you're supposed to use square braces, that'll be an error. If you do square braces where they're supposed to be curly braces, that'll be an error. Largely, the type of data structure that you're dealing with in Python is largely dictated by the type of brace that you're using, right? So tuples are round braces, lists are square braces, dictionaries and sets are curly braces, and strings are either double or single quotes, which are not braces, but function like braces. So, item retrieval, that's how you get data out. Concatenation. If you have two pre-existing tuples, you can create a new tuple by their powers combined, as so. So, if we have u being equal to 5, 6, 7, t is this, u is that, t plus u is the two of them run together. U plus t is them in the opposite order but still run together. So, what does that mean about the commutative property of addition when that operator is applied to tuples? Does anybody know what commutative means?
T plus u is equal to u plus t.
Yeah, x plus y equals y plus x. In this case, x plus y does not equal y plus x. So concatenation is not a commutative operation on tuples. Question?
Do you know that in C our Are Python tuples like linked lists? How are they stored as data type? Like their own data type, or is it?
Python goes to a lot of length to try to hide how tuples are stored. We will get into this a lot more when we have our topic specifically on data structures, but I'll tell you right now, tuples are stored statically. So to statically store a tuple as a linked list, to me, would just be stupid. So I imagine they're probably storing them as arrays in the back end, or like a struct or something, you know?
So if you can only add them together, there's one.
Well, see, it's interesting, right? Because you're creating this sort of temporarily, but T is not actually being modified here, right? Like if I call for T again, is that too low? Can you see that? Okay. If I call for T again, it's not been modified by this operation. I would have to say T is equal to T plus U. So what it's actually doing, right, is it's taking a new memory plot, right, large enough to accommodate both T and U, putting them both in, and then if you don't save a reference to that, then it's lost and gets garbage collected. Does that make sense? Cool. Question?
Conventionally, are tuples always represented by like capital letters, or if we were in a different language, would we use a lowercase?
In Python, it's common to use capital letters for data structures. In other languages, you only use capital letters for types, like user-defined types. So, yeah, it's another one of these things where, like, there's no strict requirement. It's just kind of convention, you know? But, yeah. If you want to use lowercase, then that's fine. Any other questions? Okie dokie. So, LEN is a very simple one. You give it a reference to the data structure, it returns how many elements it contains. Very simple. We also, interestingly enough, have a built-in search operation bound to the in keyword. So, if I were to say 3 in T, that's true. If I were to say 3 in U, that's false. 3 not in U is true. Make sense? There's actually like a whole loop going on in the background here. This is performing linear search, but you know, it's there for you. It's like one of these little things where, this is one of these little corners of Python where it likes to pretend that it's a sentence, you know, in English, but you know, so it goes. So those are your basic tuple operations. I already kind of demonstrated this, but tuples are immutable. Once created, they cannot be modified. So if we can get stuff out of a tuple using indexing, save it to an intermediate variable, and then that variable may be modified. But to directly try to assign something to an element of a tuple is an invalid operation. This is for memory reasons that we'll sort of get into. But again, you won't really have a great appreciation for this type of memory management stuff until you study C and do dynamic memory allocation. Okay? How many people already know dynamic memory allocation? Yep, okay. So hold on to your butts for a second semester then. So, let's talk about strings. Strings of characters. So, strings are a sequence of characters like a tuple. So, in contrast to tuples, like strings are like the only data structure which only contains one type of thing. And that type of thing is a character. And, you know, That's how it goes. So, thank you. When we want to enter a phrase encoded in characters into a program, we use either single or double quotes in Python to do so, right? The individual pieces here, the individual characters, are indexable the same way that you index the elements of a tuple. You can perform many of these types of operations. You can perform many of the same operations on tuples as you perform on strings. However, they are a distinct and distinguished data type. So, these guys here are what's known as string literals. They're not scalar, as they can be decomposed, but we might say S is equal to hello world, and there they are. So if you want, you can say S plus S, you know. You can even say S times 5. There you go. You can even say something like right? So A times 1,000 A's, plus H, plus 10 exclamation points. Right? So, and this also applies to tuples as well. The whole multiplication multiplies, repeats the, multiplication is repetition as applied to data structures in Python. Good. So, did I already talk about the single versus double quotes thing? Yeah? Okay. No? Okay. Well, so in other languages, basically any other language, a single quote denotes a character and a double quote denotes a series of characters. In Python, you can use either to denote a string of characters, because Python likes to pretend there's no such thing as a single character. Anytime you try to enter a single character, Python will think that you meant a string containing only one character. There is a technical difference, which you will definitely come to be familiar with if you go on to take 1xC3 and C programming, and frankly, programming of any other language. But, you know, that does have certain good side effects. Like you might say, for example, if I am using double quotes, how do I quote a double quote character, right? Like, let's say I wanted to say, this class is fun, right? To just write it like that means that this is a string literal, and then I've got like something that I think is a variable name, but it's not actually a variable name, and in any case, there's no operation implied here. So this is a syntax error, right? So there are two ways to approach this problem in Python. The first way is to escape the quote characters using the backslash. This is sort of your traditional way of doing this in most programming languages, right? The other way is to simply use the single quote instead of the double quote as the delimiter. So, because you started off with a single quote, it's going to wait for another single quote to finish. So anything that's inside of it that's a double quote gets picked up as a double quote character instead of a string delimiter. Question? Yes. Yeah, same applies in reverse. You can get single quotes in there by using double quotes as the delimiter. Make sense? Any questions? Cool. So, that's what that whole slide, good. So let's talk about characters. Historically speaking, most languages only allowed ASCII characters to be encoded. So, ASCII is a format for characters which dates back to the 1960s. It was originally used in teletype machines, which were some of the first early electric typewriters. Electric typewriters were, of course, some of the first keyboards, as soon as we figured out how to wire together one of those things, a monitor and a computer. They encoded characters in 7 bits, right? Which means that there was 128 possible characters representable in the original ASCII code. Most of these characters are still the most common characters that you will see and use in programming languages or just generally around. Characters 0 through 31 were so-called control characters. You then had all of these symbols. You had all of the alphabetic characters. Numeric characters first, then alphabetic, uppercase, then lowercase, with various other characters thrown in at various points. Space is 32. So you can still get these by taking a single character and asking for its ordinal value. So the ordinal value of A, for example, is 65, right? Which, if you look it up, capital A is 65 in this chart. So characters are not transmitted as characters inside of the computer system. Everything is binary. Everything fundamentally is encoded as a number. This is the mapping between numbers and characters. When you write the letter T, when you hit the T key on your keyboard, it sends the number 84 to the computer that's receiving the inputs. That's decoded because it's known as it's a character because it's coming from the keyboard, and you do with it what you will, right? There are a number of interesting characters that you might not think are real characters. There are some of these which are interesting sort of holdovers from when these things were typewriters. Some of these things are typewriter operations, like, for example, bell and carriage return. So if you've ever seen an old movie with a typewriter in it, you type, there's a piece of paper that moves this way as you type, so the type head is in a fixed location, right? And then at a certain point, it's like at the end of the line, you hit a return key, and it goes shh, ding, right? Ding. The carriage return and the bell are actually characters inside of that are both printed by the machine when you hit the return key. By the way, do you want to know why the return key is called the return key? Because it returns the carriage to its initial position. So, yes. Question?
Is there any good reason why it would be Is there any good reason why it would be
Probably because it wasn't in the, it wasn't, actually probably, yeah. Okay, here's my hypothesis, although I can't be sure, all right? Because, if you notice, delete is 127. So, would a typewriter have had a delete? Right? It's writing on ink, it's ink on paper, so there's no way to backspace on a typewriter. So, backspace, there might be backspace right here means literally, move rather than having the carriage automatically move one character in one direction, move it back one direction. But like if you've already typed a character there, then you would be over-typing character. And you know, on a manual typewriter, you just press the button extra hard so that it would stamp hard over the character that you, you know, like when you're writing math and you like, it's supposed to be a 4, but you wrote a 7 and you have to put the 4 in, you know, that's like how people used to do things. So like the concept of delete isn't really meaningful on a typewriter. So it's not surprising that it's sort of stuck on the end here. Does that make sense? Any other questions? You don't have to memorize it. So, one may notice, however, that's not actually a lot of characters. You know, there are a lot more characters than that, actually. So, over time, the character encoding format, which all computers use, has gradually been expanded to use more and more bits, which allow more and more characters to be written. Expanding it to 8-bit ASCII allowed 256 characters to be represented, which would have roughly coincided with the development of 8-bit operating systems. So, you know, it makes sense to move to 8 bits. Now, we have Unicode. UTF-16. Any guess how many bits UTF-16 uses to encode characters? It's 16. Good. Which is a lot more than 256 if you do 2 to the power of 16. Right now, I think we've hit like 142 or something at this point. These slides are a few years old now. But basically, we've got more than enough room we could ever want for any kind of characters that we want. So yeah, not all fonts have symbols for every character, obviously, but you know, all of your characters with accents, characters in languages other than English, all of these, you know, math symbols, all of these types of things, these are all extended in the Unicode set of characters, right? Which is good, because it turned out that, you know, while computers were, you know, first developed in the English-speaking world, they definitely found use outside of the English-speaking world. I think we can say that with a fair amount of confidence in the year 2022. So, yes. Incidentally, emoji are also Unicode characters. When a new emoji comes out, what that actually means is that the UTF or the Unicode format specification has been expanded to include, you know, one or two new emoji symbols. Make sense? Good. Yes. So all Python 3 files are UTF-8 by default, despite the fact that variable names are restricted to the ASCII set. The types of characters that you can use inside of strings are actually, you know, much larger than that. So you can either sort of directly copy and paste non-ASCII characters into the strings, or you can access Unicode characters directly by their Unicode, you know, their code value, using the /u, and then you specify the number in hexadecimal. So, for example, you, how's this? D83D, if we print that, it should That's interesting. At any rate, there's some way to do it. Copying and pasting it in is, I think, the easiest. It's not going to come up much in this course, but there is one question that requires you to do that. Furthermore, if you use an escaped N character, that inserts a new line. If you use an escaped T character, that inserts a tab, both of which are very useful. So, for example, this way and that hopped the rabbit. There we go. So you'll notice tab character has been inserted and replaced here. At the end of the comma, this new line has been interpreted as a jump to the next line. Notice that this space here has been printed because there is a space here after the new line, right? One common thing that you have to beat out of yourself as a bad habit is considering space to not be anything. Space is a character. Just like any other character, it takes up the same amount of space in the computer, so to speak, to put a space as to put anything else. Make sense? Good. So, operations on strings. Indexing and length both work precisely the same way as they do with tuples, so I won't go over it again. However, we do have this very interesting new operation known as string slicing or list slicing. It's a slicing operation. So the purpose of a slicing operation is to take a subpart of the data structure and sort of snatch it out and assign it to a new variable or something, whatever you need to do with it. So rather than returning a single index, it returns a series of indexes, right? So if, for example, I want the third element, there you go. If I want the third through the fifth element, there you go. Or 1 minus the fifth element. Not referencing the movie. It was okay. So, when we perform a slicing, we slice from the first number to 1 minus the second number. Alright? That grabs the bit out of the middle corresponding to these indexes. So, 0, 1, 2, 3, 4, 5, 6, 7. Boom. Make sense? This is a lot of chitter chatter. We still have 3 minutes in class left, people. So, in addition, we can count the number of occurrences of a particular substring inside of a string. A substring may be defined as a single character. It may be defined as a series of characters. So, for example, if I take my string and I want to say, how many times does the letter O occur? Twice. How many times does the double L occur? Once. How many times does the phrase simmer down occur? 0 times. The index method, if it's got a dot, if you apply it with dot notation to the thing, then it's a method. If you use the index method, it does kind of the same thing as count, but what it's actually doing is returning the index of the first occurrence of that string. All right? Any questions about any of that? Yes, sir.
So as
could you speak up, please?
Sorry. So for the occurrence to the substrate operator, can you look for more than one substrate in the string?
Well, we can try it. Maybe. I don't think so. I think that what you will have to do there is just call it twice. But let's say s.index of O and x.index of L? Nope. Incorrect. So yeah, you just do one and then do the other. Oop. Here's an interesting little tidbit though. If the thing you're looking for isn't actually in the string itself, then it'll return an exception. And that's the type of exception that you really might reasonably expect. So you'll need to know exception handling to be able to handle it. Question?
I wanted to suggest, what if you in brackets put x plus another string and then dot index?
Well, that's a good question too. So rather than using the comma, use a plus here. Is that what you're saying?
No, I actually meant earlier, like you said x, like say x plus some other string.
Oh. So like s plus s, something like that?
Sure.
Well, let me just fix it. Yeah, it'll calculate out the expression here prior to applying the method, right? So this concatenation operator will take precedence over the indexing operation. Make sense? Any other questions? Yes, sir. Yeah, I think that's a reasonable thing to do. The thing about Python is that a negative index actually is meaningful. Yeah, like the last element of a data structure, I can see you shaking your head because it's like why Python, why? But yeah, if you have like -1, like s hat -1 is the last element in the string. Yeah. Yeah, so -2 is the second last, -3 is the third last. So you can actually like reverse even. It has like some stuff you can do with it, but it's like